Hi everyone, myself Abir Koel and you are watching my new YouTube channel Competitive Chemistry, where you will get chemistry related videos for your preparation like CSIR NET, GATE, IIT JEE Main, Advanced, etc. Before starting my video, I am requesting you, if you find this video is useful for your preparation, then please like, share with your friends and siblings, comment and subscribe my channel. So without wasting any time, let's get started.
The aldol reaction. Aldehyde containing an alpha hydrogen atom undergoes reversible self-addition in presence of acid or usually in dilute alkali to give condensation product like beta hydroxyaldehyde or ketone. In every case, the addition occurs in such a way that alpha carbon of the first carbonyl compound get attached to the carbonyl carbon of the second. So the reaction is basically like this. So if you have CH3 CHO, then what it can give two molecules of this in presence of base OH minus or H plus acid, you can get CHO. So this type of molecules, this is called beta hydroxyaldehyde. And if you have ketone like acetone, CH3 CO CH3, so two molecule will add in presence of acid or base minus or H plus 3. So this is called beta hydroxy ketone. So this ionizable alpha hydrogen of a molecule will give this beta hydroxy aldehyde or beta hydroxy ketone. This is known as Aldol reaction. Now if an aldehyde or ketone do not contain alpha hydrogen, then the self condensation reaction do not occur. So which type of molecule will not show aldol reaction? ArCHO, basically ArCHO or HCHO or like CH3CHO, this is CH3CH3. So this type of molecules, or another AR is any phenyl group, CO AR. This type of molecules will not show aldol reactions. Okay, now we will see the mechanism of aldol reaction. So base catalyzed mechanism. Okay, so first step is like R CH2 CO R prime, this type of compound in presence of base. This is a reversible reaction, so in presence of base it will give R CH2 minus COR prime. So this is basically a acid base reaction. Okay, and this is very fast reaction, so it can enolize like R CH double bond C O minus R prime. So this is one first step. Then what happens in the second step? Another molecule of R CH2 CO R prime will be there, and this is a nucleophilic part, so in this step this will go there and this will attack this carbonyl and it will be like this. So basically what happens in this step, we will get this R CH2 CO minus R prime CH R CO R prime, okay, like this. And then one acid base proton transfer will be there, so like this is a base, so proton transfer will be there, and finally we will get beta hydroxy carbonyl compound RCH2 C R prime OH CH R CO R, like this. This is called Aldol. Okay, it have keto group as well as OH group, so it is called Aldol. So proton transfer are very fast reaction. If the dehydration happens, then what happens, CR prime OH CH R CO R prime. So in presence of base, it will be like R CH2 C R prime OH C minus R COR plus base, and then there will be a U1 CB mechanism. Okay, U1 CB mechanism. So what happens, this minus will go there and this OH will be eliminated, and the final product will be R CH2 C R prime double bond C R CO R. This is the alpha beta unsaturated carbonyl compound. So generally in basic medium this is the mechanism. Okay, if there is a aldehyde group, then aldol reaction will happen very fast, but in case of ketone the aldol reaction will not be that much fast. So if you consider a ketone, this R group, and there will be a R group. So carbonyl carbon of ketone is less electrophilic, because this carbonyl carbon will be less electrophilic because plus I effect of this R group. This R group has plus I effect. Okay, plus I effect. So due to the plus I effect, the carbonyl carbon of ketone is less electrophilic. This is one reason, and another reason is due to the steric hindrance, the probability of nucleophilic attack by enolate or enol is decreased. So nucleophilic attack is hampered. Nucleophilic attack is hampered. Okay, that is two reason. The ketone is less reactive than aldehyde. Okay, So now we will see the mechanism of aldol reaction in presence of acid. So do a mechanism acid in presence of acid. In presence of acid. So first step will be like this: RCH2 COR in presence of acid. It will be like RCH2 plus protonated. Carbonyl carbon will be protonated first. So it will be enolized like this, and this is called enol. Okay, now in this second step another group will be attacked. So this enol group will attack another. So RCH2 CO plus this R prime. So this will be like this attack will happen. We will get like this type of aldol compound RCH2 R prime H CHR double bond R prime. This is aldol reaction in presence of acid. Now if there is dehydration step, then we can get alpha beta unsaturated carbonyl compound. So what will happen? This OH group will be protonated. So RCH2 CH2 plus R prime CH CO R prime, and then it will eliminate, and we will get a carbocation. RCH2 C plus R prime CH R double bond R prime. Then this hydrogen will create this double. So in presence of acid we will get alpha beta unsaturated compound. So in presence of acid we can get this type of alpha beta unsaturated compound. So this is the mechanism of acidic medium. So we will see now experimental evidence. we will see this experimental evidence. Okay, in the first step of aldehyde CH3CHO, we have seen that it will go like this CH2 minus COH, and then it has done CH2 double bond O minus C O minus hydrogen, and it is attacked by this has gone there, and it will attack here, and it will go up, and then we have seen in the second step, this is first step, this is second step, we have seen this type of compound. So minus, this is CH2 CHO, and now it has gone there CH3 CHOH CH2 CHO, like this. So carrying out a reaction with DTO fails to result in the incorporation of any deuterium to the CH3 group of aldehyde. I mean, if we do this reaction in D2O medium, we cannot get this type of compound D CH2 CHO. That means the first step is reversible. So in D2O medium, we can get this aldehyde group will enolization group will there, and it will get this D also. So we can get this, but we cannot get this type of product. But in presence of ketone, we will get D CH2 CO CH3. So this type of compound we will get. This indicates that the step 2 is faster than reversal of state 1 in case of aldehyde and slower in case of ketone. Okay, so this is the experimental evidence. So the reaction can be made of synthetic importance by continuous distillation of the products in a Soxhlet apparatus. Number 2, using acid catalysis, tendency of dehydration of aldol products is increased, producing more stable alpha beta unsaturated aldehyde or ketone. Third, to stop at the aldol stage, the best catalysts are basic ion exchange resin. And fourth, a 3-degree alcohol always undergoes dehydration through U1 mechanism. Okay, now if we see some examples, so examples number 1, if we this type of compound in presence of basic medium, so what type of compound we will get after aldol reaction? We can get like this. Try at home. Okay, I will not give the mechanism, only I will draw the product. So this, and then after dehydration we can get this type of compound CH. Try the mechanism at home. Okay, then if we give this type of compound, so in presence of acid, what type of compound you will get? You can get this type of aldol product. Okay, give this type of compound, so after aldol product, after aldol reaction we can get this type of compound. So try at home. Okay, one last example is, if we give this type of compound, then what type of compound we will get? We will get this type of compound. So try the mechanism in home. Yeah? So now we will see about crossed aldol. So when one of the partner in a crossed aldol condensation is benzaldehyde, which can only act as a E plus electrophile, and another aldehyde or ketone which can form either enol or enolate, then this type of mixed condensation is known as crossed aldol reaction. Means if one of the partner of aldol reaction is like this is called benzaldehyde or any aldehyde which has no ionizable alpha hydrogen, and another one which contain an alpha hydrogen like acetaldehyde CH3 CHO. So if these two compounds are present, then what happens in presence of base? So we will get this type of compound. Enol or enolate will form from this acetaldehyde compound, and then the enolate like this will attack this compound, and finally we will get this will give beta hydroxy. So benzene minus CH2 CHO, and then after elimination reaction we will get this alpha beta unsaturated compound. So this is called crossed aldol. Means in the two partner, in case one of the compound contains ionizable alpha hydrogen like here acetaldehyde does, and another contain no ionizable alpha hydrogen, no alpha hydrogen. Okay, so in presence of base they will give this alpha beta unsaturated aldehyde. It is called crossed aldol reaction. Condition for crossed aldol reaction: number one condition, only one ionizable component will be there. Okay, so only one ionizable compound, only one ionizable compound. Number two, no other compound containing more acidic hydrogens than aldehyde or ketone. Acidic hydrogen will be only one compound, I mean no other compound containing more acidic hydrogens than aldehyde or ketone there. And number three, the carbonyl should be more reactive than the compound being enolized. So the carbonyl of the electrophile should be more reactive than the compound being enolized. So these three conditions will be there. Okay, but we will see retroaldol reaction. Retroaldol. Third is retroaldol. So what is retroaldol? because the aldol reaction is reversible, so when the aldol product is heated with a strong base, then it reverts back to an equilibrium mixture, mainly contains initial reactant. So this is the, suppose this is aldol product, OH, CH3, CH2, CO, CH3. Okay, now if we give base and heat it, then what happens? CH3, C, CH3O minus, CH2, CO, CH3. So it will be like this, and this CC bond will break, and we will get the compound like CH3, CO, CH3 plus CH2 minus, CO, CH3, and after giving aqueous medium we will get 2 molecules of acetone. So this is like reverse of aldol reaction, so this is called retroaldol reactions. So in this class we have seen the aldol reactions, which compound will give aldol reactions, which compound will not give aldol reactions, the mechanism of aldol reactions in presence of base, the mechanism of aldol reaction in presence of acid, why carbonyl compound in case of ketone gives less aldol product or less reactive in aldol reaction than aldehyde group. Then we have seen some examples of aldol reactions. Then we have seen the crossed aldol product or crossed aldol reactions, and ultimately we have seen the reverse of aldol, which is called retroaldol reactions. So why it is called retroaldol? Because it is the reverse of aldol reactions, forward aldol reactions. Okay, so this is the basic part of the aldol reactions. Next class onward we will see about some higher concepts. Okay, thanks for watching.